Welcome to qnawire.
Hi, so in this case, we are given a series of statements about the Gibbs free energy. Remember that delta G is going to be equal to delta H minus T times delta S. And we need to identify if the statements are correct or not. First of all, for spontaneous reactions, let's recall that delta G needs to be lower than zero for a spontaneous reaction. And the first statement that is given to us is that delta S is positive, meaning larger than zero, for many spontaneous processes. That is true, and it is actually favored because of this term. As you can see, here we have a negative sign, and if delta S is larger than zero, that means that we have a high chance of delta G to be negative. So the first statement is true. Next up, we are told that delta G is always negative, always lower than zero for spontaneous processes. And that is also true with the small condition that is given that pressure and temperature are constant. Because that is the condition for for something to be spontaneous for pressure and temperature constant. So this is true only on this case. Remember that the major condition for equilibrium and for spontaneity is the entropy for the reaction or for the process that you're studying. It just happens that in the case when we have pressure and temperature constant, we can define delta G, and that can tell us if a reaction is going to be spontaneous or not. Now for case C, we know that we are told that delta S must be positive for a process to be spontaneous. And this statement is actually going to be false because, as you can see, the reaction can become spontaneous if delta H, first of all, is lower than zero, and secondly, the magnitude of delta H is larger than the magnitude of temperature times delta S, right? So in that case, the value for delta G, it is going to be lower than zero, as you can verify easily, minus T delta S. So if we assume that delta S was negative, so if delta S is negative, the reaction can be spontaneous if we follow this condition over here, right? Let's put like a super easy example in that case. Let's say that the value for T times delta S was equal to minus 35 kilocalories per mole. Then delta G, that is delta H minus T delta S. This would become delta H minus 35. And you can see that for delta G to be negative, delta H needs to be lower than zero. And actually, you can directly put it that delta H needs to be lower than minus 35 kilocalories per mole. You can plug in there minus 40 kilocalories per mole, and you're going to verify that delta G is going to be negative, and thus the reaction can be spontaneous. So that is the only case that is going to be negative. Just for completion, let's verify the other statements. For statement D, we have that delta G is always positive for non-spontaneous process. And again, that is true if we consider that pressure and temperature are constant. And the last one, E, tells us that if delta S is negative, just as the case that we were stating here, then delta H must be negative for a spontaneous process. And that is also true for the same reasons as we stated here. We verified that it needs to be negative in this section and that it needs to be larger in magnitude than the T times delta S term. And that would be all. Thank you very much.